Hello guys, welcome back. And today, one of my students asked a beautiful problem rather, and I saw the problem, solved the problem for her, and I kind of really thought about a generalized version of that. So this video is proposed, like my mind proposed it that I should make a video on this because maybe it will help you out in your understanding of probability, uh, correlation, and independence. So the question started from this aspect that uh, like the basic question that we all know that can uncorrelated mean that like no uncorrelated means independent. We know that it's not true, right? But the other way around is true. We know it's not true always, except the in normal case we will like accept normal random variable. But if it's independent, we know that it's always uncorrelated. That's pretty easy to prove even. So the question was that if x is uniform, um, let's say minus theta to theta, and yeah, if x is uniform minus theta to theta, guys, so find the correlation between x and mod x. So how do you find out this? So essentially, if you take it y is equal to x and y is equal to mod x, you have to find expectation of xy because you have to find the covariance, right? For the correlation, you have to find the covariance of xy and variance of x and variance of y. Variance of x is pretty easy because it's a standard normal, not a standard normal. It's a it's a standard the standard continuous distribution. So let's try to find out expectation of xy first. So if you so that's where it struck. You get you get algebraic what should I say, an algebraic blockage because you don't know how to proceed after this. So that's why the idea is always the problem solving idea is that convert into the thing that you know already. So you know in terms of x. So can you convert xy into terms of x entirely? That's the problem solving idea. That's a very important problem solving idea that is very inherent in it's very it's spread about all the ideas that you will learn in the future. So xy therefore can be written as observe that x. Okay, so what's mod x? Mod x is nothing but x if x greater than equal to 0 and minus x if x less than equal to less than 0, right? So therefore x mod x will be nothing but x square if x is greater than equal to 0 and minus x square if x is less than 0, right? Just multiplying x. So therefore you need to find expectation of this stuff. So you have to find expectation of some g of x, right? Now you use the law of total probability. So what is the idea is the core idea is that if since it's divided into two spaces, right? It depending upon two different behaviors. So if the condition on the fact that x is greater than equal to 0 and less than y 0, right? So therefore xy can be written as, so we know the conditional aspect is that if the sample space can be divided into two parts a and b, so we can write expectation of xy given a times probability of a. So that's expectation of xy given b times probability of b. And from here you get that. So this two are this to mix up the entire sample space. So here is nothing but expect x less than equal to 0. So why we are doing this? Because otherwise we cannot, so this is a piecewise function, right? So you need to divide and condition that. That's the idea. Since it's a piecewise function, you have to condition in that way. That's the basic idea. And you get therefore. So now xy given x is greater than equal to 0, xy is nothing but x square, right? So expectation of x square given that x is greater than equal to 0 is x square, right? That's the idea when to capture into probability x greater than equal to 0 plus expectation of xy it's minus x square into probability x less than 0. right? Now, if you observe that this turns out to be the same as minus gets cancelled and minus turns out to be here, it's minus this. And this is common. So since probability x, since x is symmetric around 0, probability x greater than equal to 0 is same as probability x less than 0. So hence both of this gets cancelled. And hence covariance is 0 and hence correlation is also 0. The beautiful aspect is that, the interesting aspect is that we can generalize this idea. So we had this kind of thing that expectation of xy. Now xy turned out to be something like, yeah, xy turned out to be something like something symmetric around 0, right? So it's like if xy can be is a function, it's an odd function, as some one of my students told, is an odd function, then observe that, or it's odd function, yes, it's odd function, then observe that, let's say gx if x is greater than 0 and minus gx if x is less than 0, then it's really this will be gx times probability x greater than equal to 0 plus probability expectation of minus expectation of gx probability x less than 0. So my food for thought question for you is, guys, that find the condition, find us like, is if x is symmetric, then is f x is symmetric, then is x and are I mean these mod x and x are correlated or uncorrelated? Yeah, check that. And what kind of other functions like symmetric, x is symmetric, that's very important. So that kind of releases out this whole thing. What kind of other function y is equal to gx are uncorrelated? Like try this type of functions. Like we already seen that if xy or xgx is odd, then it may be something good, and x is symmetric, then it's also something good. So try out this problem, guys. Try out this foot of the problem. It will enhance your algebraic and some intuition capabilities. But the whole idea is that x and mod x are not are dependent on each other, right? X and mod x are dependent on each other, but still they're uncorrelated. So it shows you that it gives you an idea that if x and mod x, x and y can be dependent, and x yet they can be uncorrelated. The geometrical idea is very simple: x and mod x. If you plot x and mod x is this, and mod x is this. Mod x is this, x and mod x. So when you draw the entire, when you take, like take points from that. So since x is from minus, let's say 1 to 1, you will get, let's say, point out here like this. Let's say you will get point from, let's say this is minus 1 to 1. You will get, like, let's say you simulate it, and for simulating it, you will get points like this, let's say, uniformly within this. And when you simulate from mod x, okay, that means you simulate from x and then take it positive, this will turn out to be positive, right? So this will turn out to be something like this. Let's say it's similar. Let's say first you do it from mod x. Let's say you got this from x, and then you change to mod x. So essentially you got on the y-axis, let's say you got mod x. Or let's say, let me just, so this is x. You you simulate from x. This is uniform 0 comma minus 1 comma 1, and y is equal to, let's say, mod x. So first you take it from x, let's say minus 1 comma 1 even here, and you simulate, let's say, this and this, let's say, got it from here. And what you get, that you get their corresponding, or okay, so you get x comma mod x. You have already simulated from here, so the corresponding mod version will be along this line. So the negative version will be along So this is x. So corresponding x comma mod x will be this points. So along x comma mod x, and x comma for the negative part, it will be along this line, right? Because it's along mod x. So the idea is that it will be like it's symmetric around the y-axis, symmetric. So hence it will be correlation is 0. So the idea is that it will be symmetric. X comma mod x is symmetric. Okay. Yes, so that's it. X comma mod x is symmetric. Like it will be something like this. Around y-axis, it will be points like this, symmetric around the y-axis. So the correlation will be 0. If you kind of think in terms of distribution and data approach, right? So this is the basic idea. This is the geometry of it. Why the correlation is coming out to be 0, and this is the mathematics behind it. So I hope you enjoyed it, guys. This is something that can liberate you and make you understand the relationship between correlation, geometry, and the independence, guys. I hope you enjoy it. Think about the food for thought problem. Comment it below with your solutions. If you like it, do share, subscribe, and share it with your friends and like. And yep, if you're interested in courses for IIT JAM, MS, or ISIMS, or CMI Data Science, do check out the links in the description below. Thank you for stopping by and watching the video. Thank you, guys. I will see you in the next video. Stay tuned and stay blessed. Have a great day ahead. Bye bye.